The purpose of this video is to explore the procedures for solving absolute value equations in algebra. Now remember, what it means to be a solution in algebra is anything that makes a statement true. So we need to figure out what quantity or quantities can be plugged into these equations to make them a true statement. Before we start solving the equations, let's review what it means to be an absolute value of a quantity. The absolute value of a quantity is its distance from zero on the number line. Since distance is always positive, so is the result of an absolute value. So we use these straight brackets to indicate that we are measuring how far a value is from zero on the number line. And it's really important to remember as well that there are often two distances that have the same absolute value, one in the negative distance and one in the positive distance. So for example here, 2 is 2 units away from 0, and the value negative 2 is also 2 units away from 0. So looking at that definition of an absolute value, we should realize that most of these absolute value equations will have two answers, one from the positive direction and the other one from the negative direction back towards 0. Here's a very basic example to get started. We're looking at the absolute value of a number is equal to 4. Well, we know the distance, that is 4 to 0, has two possibilities. A positive, where we just simply say we are 4 units away from 0, and a negative. So we're looking at a negative distance of x is equal to 4. That value has to be a negative 4 to make that a true statement. So you can look at it algebraically as either dividing both sides by -1 or multiplying both sides by -1. But either way, we get two solutions, -4 and +4 for this statement. As a second example, let's take a look at something that has an operation going on inside of the absolute value to make this a little bit more challenging. Please continue to recognize that we are going to have two cases, one coming from the positive direction and the other one coming from the negative direction where our distance is 4. So first we can just look at the positive case where we can drop our absolute values and just say we have a distance of x plus 1 away from 0, and that is equal to 4. This becomes a simple one-step equation, and we subtract 1 from both sides, figuring out that x is equal to 3 in the positive direction. Now in the negative direction, we are figuring out that that same quantity, x plus 1, is a negative amount of units from 0 on the number line, and that result is a distance of 4. So there are a couple ways to solve this. Many people, once they see a set of parentheses with something on the outside, they'd like to use the distributive property first. So if that's your skill set, that's what you're comfortable with, you're welcome to do that. Then we simply add 1 to both sides, and then we can divide both sides by -1 to figure out that our value on that direction is x is equal to -5. So our solution set to this problem is -5 and 3. Be sure to go back and take a second and plug 3 and -5 back into your absolute value. 3 plus 1 is 4. -5 plus 1 is -4. You take the absolute value of that, that's 4. So both of these make this a true statement, which is what we talked about with solutions at the very beginning of this video. For the third example, let's add another operation on the inside of the absolute value to make things a little bit more complicated. A lot of times these will end up with a fraction as an answer. Please do not be scared. And also you don't need to convert anything to a decimal unless you're asked otherwise by your teacher. So again, we know that there is a value that is coming from the positive direction that has a distance of 4, and from the negative direction has a distance of 4. So for the positive case, we simply can just drop our absolute values and say 2x plus 1 is equal to 4. Perform your two-step equation, subtract 1 from both sides, and then divide both sides by 2, and we end up with x is equal to 3 over 2, or 1.5. Coming from the negative direction, we realize that a negative value that has a distance of +4 is equal to negative parentheses 2x plus 1. We can simply, instead of using the distributive property, we can actually do a second method, which is divide both sides by -1 right away, and realize that we can just drop the negative on the left and make the value on the right negative. So we have 2x plus 1 is equal to -4. We can solve this in the same way we did with the positive value now, and we end up with x is equal to -5/2 in this case, or you could think of this as -2.5. So our solutions are -2.5 and -1.5. Again, be sure to plug these answers in. Don't be intimidated by the fractional form. You realize that when you plug both of these in, 2 divided by 2 will cancel out, so your procedures will be pretty easy. Next, for our fourth example, you'll notice that sometimes your textbooks will give you problems that have operations on the outside of the absolute value. What I would do is treat that absolute value like your variable in a regular algebra linear equation and isolate that before you go into the two possible outcomes. So I would get rid of the negative 4 on the left-hand side by adding it to both sides, and then simply divide both sides by 2 to make this a much more user-friendly problem to deal with. Absolute value of x plus 1 is equal to 10 is much easier than the problem we dealt with at the beginning. So realize that if we didn't get rid of those operations, we'd have to look at both the positive and the negative distance with both of those operations twice. So you're really saving yourself some time by breaking it down this way first. And now we can look at an example that's very similar to our easy one from example 2, where we can just simply drop the absolute value on the left-hand side and subtract 1 from both sides to get x is equal to 9. For the negative case, now we can either distribute that negative or we can divide it by negative 1. Most of us, after going through a couple of these, will realize dividing by a negative 1 is much simpler. Some teachers even just go right to that part. I don't like to do that, especially when we get into the absolute value inequalities. People don't realize that when you have to break this down, it does break down in this way, and that negative doesn't start automatically on the right-hand side. So we go back to the x plus 1 is equal to negative 10. Again, we're down to a one-step equation where we can subtract 1 from both sides and realize that x is equal to negative 9 for our second solution. Now please take these two solutions, negative 11 and 9, and put them back into the original equation, not this shortened one. You want to make sure that makes that statement true. And we test both of these, and both values make the original absolute value equation true, so we know we did a good job in this case. Now for our last example, I'd like you to remember that it's important not to become too robotic as we're going through these problem sets. Remember the definition of an absolute value. The absolute value is the distance from 0 on the number line, and we know that distance is always positive. So we take a look at the absolute value of x plus 1 is equal to negative 4, and we should realize that there is no way to get an answer to this problem because we don't have a negative distance from 0 on the number line. So this problem has no solution. It's very important as we go forward to pay attention to the details and not get too robotic as we go through our problem sets. Always check your solutions as well. If you do go through this problem not realizing what's going on, when you plug your solutions back in, they won't make sense at the very end. So that's it. Hopefully some of these examples were helpful to get you through your problem sets in your algebra class. Now I realize that as you go forward you will take some shortcuts, but it's important to set a foundation before we start taking these shortcuts so we don't miss any conceptual understanding along the way. Please realize that you will be using absolute values in equations later on in, say, statistics or a more advanced math course where you need to have a positive outcome. So please keep that in mind and keep these skill sets fresh for those cases where you'll need to use them in the future. Thank you so much for watching. Please take a look at my channel for more videos on algebra and other topics in mathematics.